Alright, the purpose of this lesson is to very quickly just summarize the conceptual and the computational methods of calculating some of the friends, if you will, that you've met during this module thus far. So we'll start at the top, SSXY, which recall is the numerator in our calculation formula for R. And again, I'm not going to read this to you, but it's presented here. And what I did is remind you that regardless of how you calculate it, you would come up, in this case, with SSXY of 28. The next two items are the sums of squares in X and the sums of squares in Y. And as it turns out for this set of data, both of them are 40. So again, it doesn't matter which, in this case, which X or Y we're looking at, or which method you're doing it, conceptual or computational. But the sum of squares in X is 40, and the sum of squares in Y is 40. And then mathematically, how do you calculate the standard deviation in X and Y? And then conceptually, where does that come from? Again, this should be a review from one of the first lessons and one of the first things you did this term. So again, for X, the standard deviation is 3.16, and Y is also 3.16, regardless if you do it conceptually or computationally. I did this again for a couple of reasons. I think it's good to see them side by side so that you can relate conceptual to computational. I think it's easy. It makes it easy to see the numbers as well. And then I guess lastly, you're getting ready. I think you need to watch one more video before you can do step 3 of the correlation homework. But I think it's good for you to see that once you do most of those initial calculations, those 5 columns, and determine what n is, you've got everything pretty much that you need to do the math to find correlation, to find the slope, to find the intercept, to determine how good your interpretation is. So I think this is, again, not really very long, but I wanted to do it to show these two items side by side.